gentleman, the Vice Chairman of the Subcommittee, for the remaining time.
Thank you, Mr. Chairman, for calling this hearing today on the Internet of Things, or IoT. And I'd like to extend a warm welcome to Dr. Gary Butler from my hometown of Pearl, Mississippi, on the panel this morning. Dr. Butler is the founder, CEO, and chairman of Camgian Microsystems, headquartered in my district in Starkville, Mississippi. Camgian is driving information and innovation in the industrial IoT world and pioneering efforts to use cutting-edge solutions to help address our growing infrastructure problems in the United States. Camgian's award-winning IoT product, Egbert, released in October of 2014, is an end-to-end software application specifically designed to intelligently manage large volumes of complex sensing and processing operations. The distributed computing feature of the Egbert design, otherwise known as edge computing or fog computing, utilizes multi-sensor and information processing technologies to deliver real-time, actionable intelligence to users for the network's edge. Egbert was designed to provide commercial and government customers a broad range of services for remote monitoring applications such as smart infrastructure and condition-based maintenance. As an example, Egbert powers the new Intelligent Decision Support, or IDS, system for the U.S. Army Corps of Engineers, which is currently installed on the Markland Lock and Dam on the Ohio River. I'm looking forward to hearing from each of the witnesses today to learn more about how IoT is improving our quality of life, safeguarding the flow of commerce, and strengthening our economy. With that, I yield back.
Thank you. The gentleman yields back, and this time the chair will be the Vice Chairman of the Subcommittee for 5 minutes.
Thank you, Mr. Chairman, and what an incredible group of witnesses and the excitement that we sense and see of where we're going on this. And so, Dr. Butler, welcome. We're glad to have you here. And what year did you start Camgian?
2006.
Okay, 2006, and we're now 2017. Did you envision the progress that you would have made to this point when you talk about where we are today with IoT?
I didn't. I think we're making great strides in the United States in advancing this technology. I think the opportunity for the United States is significant, both domestically in terms of operational savings and productivity, but also as a business that we can propagate to the rest of the world.
Let's talk a minute about what is an important issue and an ongoing almost crisis, and that's our aging infrastructure that we have in this country. I know the president was in, I believe, Ohio recently, and your company, Camgian, along with Egbert, your technology that you have, tell us a little bit more about how that's impacting, particularly at the Markland Lock and Dam on the Ohio River, and what you see is this technology to help us with that aging infrastructure.
Sure. Our software has been built to provide enterprise remote monitoring applications. So, for example, it's very flexible in terms of integrating advanced industrial sensors and then also integrating the sensor processing and analytics associated with that data. So we can build very scalable products that can extend out to this type of infrastructure. Now, when considering the aging infrastructure problem, one of the problems that we have in the United States today, a lot of these large critical systems were built more than 50 years ago with a 50-year lifespan. So what we're seeing now is that the unscheduled maintenance of these systems is rapidly increasing. So in addition to new innovations in terms of repairs and refurbishment, concrete and steel, it's our thesis that data can bring a lot to that market by making these systems intelligent, by imbuing these systems with sensors and communications and analytics technologies can provide both engineers and operations personnel real-time valuable insights into the structural health and operational conditions of these systems over time. And so they can use that information to make better decisions about how to address some of these problems before they become failures. A system like the Markland Lock and Dam, for example, if that system goes down, it's millions of dollars of economic impact to the local economy per day. So it's very important that these systems maintain significant uptime in their operations.
And these sensors and this information that's gathered real time, it allows you to know when there's perhaps a crisis, perhaps a problem that needs immediate concern, and helps them stay on a better maintenance schedule, I assume.
That is correct.
Okay, that's great.
That is correct.
You know, you also stated that the industrial Internet of Things applications certainly are driving some amazing revolutionary gains in businesses. So what you're doing there is through the Army Corps, U.S. Army Corps of Engineers there at Markland. But talk about it, what you think we're going to see or what we should look for is how this really benefits businesses on what you're doing.
Sure. I think that same model, when it comes to improving downtime and reducing failures in mechanical systems, it applies and extrapolates across a number of industrial markets today. That includes areas like manufacturing. It also includes areas like agriculture. It includes areas like transportation, healthcare, energy, for example. Any of these industries that rely on equipment to drive their business model, these types of efficiency gains are enormous in terms of significantly reducing any downtime in those systems, and then also the aspect of security and safety with the failure of these types of systems. So the type of work that we're doing with the Corps of Engineers today, I think, also applies across the industrial industry, or industrial market and sector in general, and not only applies obviously to domestic problems that we're addressing here in the United States, but also around the globe.
So when we're looking at this, particularly how we make sure that Congress doesn't get in the way, what do you have any thoughts as to what we can do to help as we develop the industrial IoT?
Yeah, good question.
This is your chance to give us advice.
Sure. I think, you know, Dr. Bachman said a moment ago that this is the most significant technology trend of the 21st century, and I agree with him on that matter. This could be an enormous job creator for the United States in the sense that the value that can be extracted from industrial IoT technologies is enormous across industries, as we've heard. So as it relates to what the federal government can do, I think really three things. Number one is to lay out a national strategy for IoT that's focused on becoming the leader in the world. Number two, serving as a catalyst to start this market. That has been done previously with the Internet, the DoD, and the ARPANET. I think we need to do the same thing in the industrial IoT, and I think smart infrastructure is a great place to start. Because if we can build and deploy systems in that market, that will extrapolate to other markets and help us grow, again, both domestically and internationally. And if you think about job creation, if I were to, as a high-tech company executive, if I think about scaling my business, the jobs that would create are product engineering jobs, jobs for electrical engineers, jobs for mechanical engineers, jobs for industrial engineers, computer scientists, service jobs. So there are lots of jobs that can be created here, and we can service the world with these types of technologies if we decide to take the lead in the market.
Dr. Butler, I hate to cut you off, but I'm way over on my time.
Oh, sorry.
But, thank you so much. Very informative, and with that, I yield back.
Thank you.